Hello everyone, I am Spoorthi studying Information Science in Sri Venkateshwara College of Engineering, Bengaluru. Welcome to my technical seminar on Dynamic Replication Policy on HDFS using Machine Learning Clustering. This is under the guidance of Mr. Chetan, who is an assistant professor in the Department of Information Science in SVCE. Here are the contents. First, I will introduce the topic by giving the causes, then provide some basic related background, that is, what is Hadoop distributed file system and its replication policy. After that, what is machine learning clustering and the dynamic replication policy. Later, we will go through the literature survey, followed by the work and the implementation. Finally, I will conclude by talking about the future enhancement and the conclusion. Also, we'll be providing the references. Introduction. The rapid growth of data in recent years has given rise to the field of big data science. Distributed file systems DFS such as Google File System GFS and Hadoop Distributed File System HDFS are commonly used to handle big data. DFS must provide data availability and system reliability through file replication in case of failure, but replicating files in different locations consumes storage space and resources. HDFS default replication policy causes imbalances in the input and output. Hence, we introduced Dynamic Replication Policy using machine learning clustering, that is DRP-MLC on HDFS. So this DRP-MLC clusters files into groups based on importance using unsupervised learning. Different replication policies are applied to each group to reduce storage consumption and improve read-write operations. And this importance is determined by file usage frequency. The system aims to maintain HDFS availability and reliability as HPDC, that is, High Performance Distributed Computing. Related background. HDFS, Hadoop Distributed File System. This is a distributed file system for processing big data, dividing and replicating data blocks across multiple servers for fault tolerance and scalability. What is HDFS replication policy? So this determines how many replicas of each block to maintain and where to place them in the cluster. The default policy is to keep 3 replicas, but it can be customized to meet specific needs. Let's discuss more about HDFS basics. So what is Hadoop? Hadoop is an open source framework from Apache and is used to store, process and analyze data, which are very huge in volume. Hadoop is written in Java and is not OLAP, that is online analytical processing. It is used for offline processing. It is being used by Facebook, Yahoo, Google, Twitter, LinkedIn and many more. Moreover, it can be scaled up just by adding nodes in the cluster. Now we can define HDFS, which means that the files will be broken into blocks and stored in nodes over the distributed architecture as shown here. Machine learning clustering. Here is a pictorial representation of machine learning clustering as an example. So, clustering in machine learning is a technique that involves grouping similar data points together based on certain characteristics or features. The goal of clustering is to identify patterns or structures in the data and to group similar data points into clusters or subsets. Clustering is an unsupervised learning technique, which means that the algorithm tries to find patterns in the data without being given specific labels or categories. Clustering can be used in the various applications such as customer segmentation, image processing, and anomaly detection. Here, in the context of HDFS blocks, it is used to group blocks based on their access patterns with the aim of creating a dynamic replication policy that optimizes data access performance. Now, What is Dynamic Replication Policy? This involves using ML algorithms to cluster HDFS blocks based on their access patterns and then adjusting the replication policy based on the clustering results. This approach enables HDFS to dynamically adjust the number and placement of replicas based on changes in data usage patterns. Literature survey. Here are some interesting papers related to our work. Firstly, towards adaptive replication for hot or cold blocks in HDFS using memcached. This author proposed a dynamic replication toolset to address performance issues caused by temporal file popularity and integrated a memcached server into Hadoop to leverage in-memory processing. This outperforms traditional infrastructure and vanilla memory algorithms in terms of throughput and execution period. Similarly, DRF-FTS, a dynamic replication factor replication scheme based on fault tolerance set. The author proposed a dynamic replication approach that classifies data into different types based on popularity and uses fault tolerance sets to improve data reliability. Compared to traditional FTS and random replication strategies, their approach results in improved read performance and higher data reliability. We also found papers that discuss the Hadoop framework, that is, Hadoop, an open source framework for big data. This paper discusses the open source Hadoop framework for storing and processing large amounts of data. It has two components. One, the HDFS for data storage, and two, MapReduce for data processing. HDFS uses the concept of write once, read many, and is suitable for storing data from terabytes to petabytes on a cluster. Another paper, Applications of Machine Learning Algorithms for HDFS Big Data Security, where a new algorithm is developed to balance privacy and security in ML and provide fair and secure scientific investigation. Analysis of network datasets is done to detect intruders due to the fast-moving cyber attacks in network access environments. Work or the implementation. Let's discuss our work on this topic. There are 5 stages. First, HDFS log files. Second, data preprocessing. Third, aggregated files features database. Fourth, key means clustering. And finally, fifth, applying new replication policies. Here is the DRP-MLC architecture. We will discuss the diagram once we will learn all the 5 stages. 1. HDFS log files. Imagine a big company like Google or Facebook that stores a lot of information like photos, videos, and documents. This information is stored in a system called Hadoop Distributed File System, in short HDFS. The HDFS system saves all the activities that are done on the files like reading, creating, updating, and deleting. These activities are stored in what we call log files. HDFS log files are crucial because they save all operations for all files in the log files. The operations that are saved include reading, creating, updating, and deleting. These files contain valuable properties for the files stored in structured records. The records structure helps in selecting and extracting file features and applying preprocessing. The HDFS audit log file contains details about the operations on each file, such as the date and time of the operation, operation type, username, user IP, file location, and file name. 2. Data preprocessing. The data in the log files is really important because it contains all the details about the files. However, it's not easy to use this data as it is. Therefore, we need to apply a process called preprocessing. This process helps us to select and extract important features of the files. For example, we can get the name of the file, when it was accessed, and what type of action was done on it, like reading or updating. We can also calculate things like how many times a file was accessed, the average time between each access, and the size of the file. So, the pre-processing stage is applied to each record in the log files to select the file features like file name, access date, and operation type. Then aggregates all features for each file to extract new features like access count, average of date between accesses, and days from last access. Also, the file size is an important feature and get it for all files from the Hadoop Web Application Programming Interfaces. This pre-processing is triggered when a new record is added to the log file. So, we use the aggregated files features database to save the file features results. This is the flow diagram for pre-processing and dataset construction. Start, then initialize allowed operations array, then check if there are any records in the log file. If no, then that's the end. If yes, then initialize variable record to the first record in AFFDB. Then split the record to get the features. Now check if the value of the operation type feature is in AOA. If no, then again check if there are any next records in the log file. If no, that's the end. If yes, then record becomes next record and split the record to get the features and follow the following steps. Now check the value of the operation type feature in AOA. If yes, then check file name exists in AFFDB. If no, then calculate the other features and the ADB FAD will be calculated in the next record using equation 1. Then add file features in AFFDB. Then follow these steps. Here, if the file name exists in AFFDB, then recalculate the other features and recalculate the ADB FAD using equation 2. Then update the file features in AFFDB. Then check for next records in the log file. If yes, record is equal to next record and repeat the process. If no, that's the end. 3. Aggregated files features database. All of this information that we get from pre-processing is stored in what we call the aggregated files features database. In short, AFFDB. This database stores information about all the files in the HDFS system. You can use this database to group similar files together. The aggregated files features database saves and optimizes the aggregation process of file features. Each file in HDFS has one record in AFFDB with multiple attributes representing the features. A defined array called Allowed Operations Array AOA contains only the operations to be processed. The algorithm loops on each record in the log file, splits it and extracts feature values. ADBAD, average difference between access dates, is calculated using equation 1 as shown here and stored in AFFDB if the file is new. ADBAD is calculated using equation 2 shown below if the file already exists in AFFDB and features of the files are updated. AFFDB is used as the dataset for training the k-means algorithm. 4. K-means clustering. Now that we have all the information about the files and we have stored it in the AFFDB, we can use clustering technique. Clustering groups comparable items into separate groups. K-means is the most used algorithm for data clustering and works by grouping data into k-clusters. DRP-MLC uses K-means clustering algorithm to cluster HDFS files into 3 clusters: hot, warm and cold. files are assigned to clusters based on their features. Like, hot cluster has important files with high access value, recent last access, and 3 times replication policy for high availability. While cold cluster has unimportant or dead files with low access and higher average between each access. And ECRS 63124K replication policy is for file availability of the 3, but it is a complex recovery in case of failure. Warm cluster contains files with medium feature values and 2 times replication policy for 1 extra copy of the file. The 3 times replication policy is applied to files in the hot cluster for high availability. The 2x, that is 2 times replication policy, is with 1 extra copy of the file, 2 availability, and 100% overhead in storage. New files added to HDFS are by default in the hot cluster and later move to another cluster or stay in the hot cluster based on their actions. 5. Applying new replication policies. After we have grouped the files into different clusters, we can then apply different replication policies to each cluster. Replication means having multiple copies of the same file. This is important because if one of the file is lost, we can still access it from another copy. We can apply different replication policies to different clusters based on how important the files in that cluster are. The Apache Hadoop is an HPDC that supports HTTP REST APIs to interact with the HDFS. So, after the system determines the new clusters of the files, it will call the HDFS API endpoint to apply the new replication policy for each file. The DRP MLC architecture. This architecture summarizes the above 5 stages. HDFS log files are essential in tracking all operations performed on files stored in HDFS. And this is the heart of the system. The log files record operations such as reading, creating, updating, and deleting of files which are saved in structured records. To use this data effectively, a pre-processing stage is applied to select and extract important features such as file name, access date, operation type, access count, average date between accesses, and file size. The extracted features are stored in the Aggregated Files Features Database AFFDB, which optimizes the aggregation process of file features. Now, K-means clustering is then used to cluster HDFS files into 3 clusters based on the features, namely hot, warm, and cold. Replication policies are then applied to each cluster to ensure file availability in case of data loss. Future enhancement. There are a few things that we can do to make this system even better. 1. Experimentation with additional clustering algorithms. The current implementation of the Dynamic Replication Policy uses the K-means clustering algorithm. However, there are other clustering algorithms such as hierarchical clustering, DBSCAN, or spectral clustering that could be explored to determine their effectiveness in comparison to K-means. By experimenting with different clustering algorithms, we can identify the most suitable one for our specific use case and improve the performance of our dynamic replication policy. Second, the use of advanced ML techniques. In addition to exploring clustering algorithms, advanced machine learning techniques such as deep learning, reinforcement learning, and ensemble methods can be used to improve the performance of the clustering model. These advanced techniques can help to further refine the clustering process and improve the accuracy of the model. By utilizing these techniques, we can make our dynamic replication policy even more efficient and effective. 3. Improved selection of K-value. Currently, the dynamic replication policy selects the optimal K-value using the elbow method. However, there are other approaches such as SILET method that could be explored to determine the best K-value. By implementing a more sophisticated approach, we can obtain even better results and improve the accuracy of our application policy. 4. Integration with cloud-based systems. To support large-scale processing and storage of big data, the Dynamic Replication Policy could be integrated with cloud-based systems such as Amazon Web Services, Google Cloud, or Microsoft Azure. This would enable more efficient and scalable data replication policies. By leveraging cloud-based systems, we can improve the performance of a dynamic replication policy and handle larger volumes of data with ease. 5. Evaluation of the system under different workloads. The performance of the dynamic replication policy should be evaluated under different workloads to determine its effectiveness in different scenarios. For example, the system could be tested using a mix of read-intensive and write-intensive workloads to evaluate its performance in real-world scenarios. By testing the system under various workloads, we can identify potential weakness and areas for improvement and make adjustments to the replication policy accordingly. Conclusion: Dynamic replication policy using machine learning clustering, that is DRP-MLC, is a system that uses machine learning clustering to cluster HDFS files based on their importance. This allows for a more efficient use of storage space and helps to ensure the availability of files. DRP-MLC has 3 clusters known as hot, warm, and cold clusters. The system applies different replication policies to each cluster to enhance the consumed storage space of the replications while keeping the files availability as much as possible. As a result, DRP-MLC reduces the replication space to about 50% of the default Hadoop replication size. This means that less storage space is needed to keep multiple copies of files. Additionally, DRP-MLC improves the read and write operations time by 28.2% and 29% respectively, compared to CPHA-RIF, which means cloud provider for high availability, redundant, independent files. Therefore, DRP-MLC is an innovative system, and the results of this have shown significant improvements in read and write operations time compared to other similar systems. References. So, here are the reference links that we have referred to this topic. Thank you all for watching this video. I hope that you found this informative and valuable. Lastly, don't forget to subscribe to my channel. Please like, share and comment. Bye.